Alright, when solving a circuit, we need to identify the circuit. So here we have a circuit where we have two branches, and in one branch there's two resistors in series, and this branch and this branch are in parallel with each other. So if we put in some values, R1 equals 10 ohms, and R2 equals 20 ohms, and R3 equals 30 ohms, and we have a 24 volt source, we have enough information to solve this circuit. So where do we start? Well, I always like to redraw the circuit to solve. First of all, what we're going to do is we're going to take these two resistors and combine them into one. So we'll redraw that circuit so we can see that. So R1 will stay the same at 10 ohms, and this resistor here is going to change. So because it changed, it's going to change to R2 3. That equals 50 ohms, because two resistors in series is added. Now we got two resistors in parallel, so we have to use, well, we don't have to, but we're going to choose to use the product over the sum method to find that. We want to find RT. So we're going to take these two and squish them together to make one. So this is what our new resistor will look like, which is basically R1, 2, and 3 combined, which is RT. So we can take 10 ohms times 50 ohms divided by 10 ohms plus 60 or plus 50 ohms, and RT is going to equal 500 ohms divided by 60 ohms. RT will then equal 500 divided by 60, 8.33 repeating. So in this instance, RT is going to be 8.33 ohms. Great. Well, because we know our voltage, and we just solve for our total resistance, we can use Ohm's law to find our total current. So 24 volts divided by 24 divided by 8.33 is 2.88 amps. Perfect. And we also know if we have 24 volts here, that in each parallel branch we're going to have a total of 24 volts. So we can write that in, 24 volts here. Now this whole branch has 24 volts. So this resistor does not have 24 volts, and that resistor does not have 24 volts, but combined going across it has 24 volts. So we're better off writing it over here. So V2 3 equals 24 volts. We can find the current for this branch here, because 24 volts I2 3 equals 24 volts divided by 50 ohms. So I2 3 will equal 0.48 amps. Great, so R3, or I3, will equal 0.48 amps, and R2 will equal 0.48 amps. Now we can find V2 and V3. Well, V2 is 20 times 0.48, 9.6 volts, and V3 is 0.48 times 30, 14.4. These two should add up to 24 volts. So we've solved everything for these two, and we just need to solve for this one. So Ohm's law says I1 equals 24 volts divided by 10 ohms. I1 equals 2.4 amps. So if this is 2.4 amps, we can verify our full circuit. We should be able to take 2.4 amps here on this branch. So current coming up this way is 2.4, and the current from this branch here is 0.48. They should total up to a total current of 2.88 amps, and they do. So that's just one way to check our circuit.